Hello and welcome to my book report. So I'm doing this report on the book The Quantum Enigma, Physics Encounters Consciousness by Bruce Rosenblum and Fred Kuttner. I'm doing it this way because I really want to solidify these concepts in my mind. I like this book a lot, and one of the best ways that I know other people too, but me especially, learn is to teach the information that I'm trying to learn. I'd rather just teach it to myself, so I'm making this video for me. I'm not trying to teach anyone else about the content of this book. I just want to learn the information better. I am extremely unqualified to be teaching anyone except maybe myself about this subject. I am not a physicist, I am not a physics major, and I just really like the information. I find it super fascinating. I do want to say that I am just sort of interpreting this book as I go through it for the third time, but I might get stuff wrong. I have no formal physics background, and if something I say is not right, that's not the fault of the authors. That is totally the fault of me and my interpretation of it. Secondly, I want to give all credit to the book. My source is the book. My quotes come from the book. My information comes from the book. My interpretations are based on the book. This one book. The book. All credit to the authors. Thanks for writing this book. I first encountered quantum theory in more detail when I was 20. I'm 23 now. I was walking through the library at my university and I stumbled across a book called In Search of Schrodinger's Cat by John Gribben. And I checked it out and never returned it. I still have it. I started reading it and I thought it was super interesting how you can put all of the quantum theory, most of it, into just layman's terms that anyone can understand, just really not complicated stuff, but interesting. As I was reading this book, I kept waiting for Gribben to get to the point. What's the point? What's the big reveal? I finished the book and I was so unsatisfied, because that's the thing about quantum theory, is that there's no neat and tidy conclusion. It doesn't really make sense. The facts are the facts, but the interpretations and the theories and the possibilities, they just go off in every possible direction. There is no neat and tidy conclusion. That was 3 years ago. I haven't stopped trying to learn more about what I can as a layman who is fascinated by the topic. So just to recap, this video is not for you. I don't care if you watch it. I don't care if you don't like it. I don't care if you like it. I'm trying to teach myself better, more better. So without further ado, chapter 1. I cannot seriously believe in quantum theory because physics should represent a reality in time and space, free from spooky action at a distance. Albert Einstein. So Einstein had a little problem with quantum theory. He was bothered by the fact that the theory required observation at one place to instantaneously influence what happened somewhere far away without involving any physical force between the two. He called this spooky. He did not like it. He was also bothered by the theory's claim that you looking at or observing a small object like an atom is what caused it to be there. In theory, since our big world is made up of little things like atoms, quantum theory should also apply to the big things. It just doesn't. There's not a good reconciliation between the two. Einstein once said, half joking, this is not an exact quote, "Do you believe that the moon is only there when you're looking at it?" I learned in psychology that that's the perspective of a really young kid, like 2 years old. Object permanence, right? When you close your eyes, the thing is still there. Whether you close your eyes, open your eyes, you put it underneath a cup, it's still there. So when Einstein says, "Is the moon only there when you're looking at it?" we automatically resort to common sense. Of course the moon is still there. We learned object permanence when we were babies. But quantum theory challenges that. It suggests that there is no physical world without observation. So quantum theory is not just one theory in a big swarming sea of theories in physics. Quantum theory is the framework from which all the other theories are built on. It's super successful in the sense that not one of its theories have been proven wrong. And while it is successful, it is super strange. It challenges what we consider to be common sense. So here's some intuitions that we share. Common sense. One singular object, one thing, can only be in one place at one time. So my mason jar with the lipstick on, this mason jar could only be right here, right now. It exists nowhere else in the world at this moment in time because it's here. Okay, there's one. The second one, if you are sitting here thinking about something to yourself and you make a decision, and that's it, that's all that happens, that has no influence, no effect at all whatsoever on anything anywhere else. You just sitting here thinking. If I sit here and I decide that I want my dad to go pick me up some frozen waffles at the store, it hasn't happened. It's not gonna happen just because I thought about it. Me thinking about it doesn't do anything. It's the physical intervention that comes after the birth of a thought that makes things happen, but not the thought themselves, right? Third one, we already kind of talked about this. The world exists whether or not we're looking at it, right? Quantum theory challenges all of these common sense intuitions. So we've talked a little bit about Einstein's problem with it. We've talked a little bit about how common sense isn't so common sense, but what is quantum theory? Quantum theory was developed in the early 1900s to explain the mechanics or the logistics that govern the behavior of small particles like such as atoms. Quantum mechanics includes experimental observations and the quantum theory that explains those observations. Quantum theory is at the base of every natural science. It's at the base of why the sun shines, why the grass is green, why the universe developed, why a television picture shows up on your screen, and all of modern technology. Quantum theory has a little hand, little foot, huge hand or foot in it, for lack of a better. So, classical mechanics. An object in motion stays in motion, an object at rest stays at rest. Gravity, blah, 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 blah. Newtonian physics works for the big things. You knock something over, it falls down. You push a ball, it rolls until friction makes it stop rolling. Classical physics is fundamentally flawed because it only applies to the big things, but the world is not just made up of the big things that we can see, like that lamp and that pitcher and that box of Kleenex. The world is also made up of really small particles, like such as atoms. Why is this not something that is in the forefront of everyone's mind, like Copernicus's realization that the Earth is not the center of the universe, or Darwin's theory of evolution? Because those things are kind of like simple concepts to grasp. It's not super hard to understand. If you try to summarize quantum theory, it makes it sound almost mystical. And it's really, really not mystical. It's not. I'm going to offer you 3 summaries that were found in the book. 1. Observation can influence the behavior of something else really far away, even if there is no physical force between the two. Not a string, not whatever. And I'm talking real miles and miles away. Your observation of something here can influence the behavior of something miles away. This is what Einstein referred to as spooky, but it has been demonstrated by scientists to exist. 2. One thing can be in 2 places at one time. You observing it in one place or the other is the thing that causes it to be in one place or the other. Doesn't make great sense, does it? Welcome to quantum theory. 3. Quantum phenomena can be directly demonstrated for small particles like such as atoms. However, it cannot be applied to the big things yet. The scientists, real scientists, they have not found a way to reconcile the 2 worlds, the teeny tiny quantum world and the big classical Newtonian world of physics. There is just not a bridge between the 2. Quantum phenomena cannot be directly demonstrated with big things, and classical physics cannot be demonstrated and applied to smaller things. To summarize, classical, big, no detail. Quantum, detail, no big.